Most modern survival gear is built on the assumption that durability equals strength and strength equals superiority. Steel is stronger than bone. Polymer is tougher than sinew. Synthetic fabrics outperform hide. That logic seems unassailable until you examine how prehistoric communities actually lived, hunted, migrated, and survived in environments that, honestly, would expose the weaknesses of much of our modern equipment in just a few weeks. The overlooked reality is this: bone tools were not primitive substitutes for better materials. They were highly specialized, renewable technologies engineered within ecological limits. They represented a level of environmental integration that modern gear often ignores. Where we design tools to dominate nature, prehistoric people designed tools to cooperate with it. That difference, more than hardness or tensile strength, is what made bone tools smarter. To understand that, we really have to look beyond museum display cases and into the systems that produced, maintained, and relied upon these tools over thousands of years. Bone tools emerged from necessity, but they evolved through precision and accumulated knowledge. By the Upper Paleolithic period, which was, roughly 40,000 years ago, bone and antler were being shaped into needles, harpoons, spear points, fish gorges, awls, and pressure flakers. This was not crude improvisation. It was a long technological tradition, refined across generations. Bone behaves differently than stone or metal. It has a fibrous internal structure that resists snapping under tension. It flexes slightly before breaking. In cold environments, it does not become as brittle as some stones. For Arctic and subarctic cultures, this really mattered. A broken tool in winter was not just an inconvenience. It could mean failed hunting, failed clothing repair, and, exposure. Consider the development of eyed bone needles around 20,000 to 30,000 years ago. These allowed tailored, fitted clothing from animal hides, not just simple draped furs, but shaped garments stitched tightly enough to conserve heat. This was technological innovation directly tied to survival during glacial climates. Steel needles perform the same task today, but the innovation was conceptual precise stitching as an insulation strategy. Bone tools were not just durable objects, they were parts of adaptive systems. These tools were integrated into entire subsistence strategies rather than isolated implements. Modern survival gear is typically modular and replaceable. If a knife breaks, you just buy another. If a tent pole fails, you substitute aluminum or carbon fiber. But prehistoric communities operated differently. Their tools were embedded within hunting cycles, seasonal migrations, and animal processing traditions. When a large animal was taken, mammoth, bison, reindeer, it was not simply food, it was, in fact, a materials depot. Meat fed the group, hide became clothing and shelter, sinew became thread and cordage, bone and antler became tools. Nothing was wasted because, honestly, redundancy required it. A bone harpoon carved from reindeer antler in Ice Age Europe was shaped specifically for cold water fishing. Barbs were designed to detach and remain lodged in prey, connected by sinew lines. This detachable head system prevented line breakage and preserved the shaft. Modern fishing technology actually replicates this principle with toggling harpoon heads, but the original design emerged from resource conservation. Losing a carved antler head was costly. Designing it to be recoverable was intelligent engineering under scarcity. That mindset, designing for retrieval and reuse, really stands in contrast with modern disposable production. Bone tools, you see, were part of a closed-loop system. They aligned with energy expenditure and replacement rates that the environment could actually sustain. It's easy to assume that bone just disappeared as soon as metal arrived. But archaeological evidence, it actually contradicts this. Even into the Bronze Age and Iron Age, bone tools persisted right alongside metal. So why was that the case? Well, it's because bone possessed qualities that metal did not always offer. It was lighter, for one, it didn't corrode in the same way, and it required no smelting infrastructure at all. For fishing communities in Scandinavia or in Arctic North America, bone and antler remained optimal materials for certain tools well into historical periods. In warfare contexts, bone arrowheads were sometimes preferred for specific uses. They could be shaped to splinter in ways that stone just could not. In maritime cultures, bone fishhooks, well, they remained superior in saltwater contexts, where early iron corroded rapidly. Metal represented power, status, and offensive capability. Bone, on the other hand, represented reliability and independence. In regions without easy access to ore or trade networks, bone tools preserved autonomy. A community that could produce essential implements from hunted animals did not depend on external supply chains. This distinction, mirrors later military history. Armies that relied entirely on complex industrial supply systems often faltered when logistics failed. Prehistoric societies, by necessity, built technological resilience directly into their materials. Modern gear often fails at its most complex points. Zippers break, composite materials delaminate, electronics malfunction in moisture or extreme cold. Repair frequently requires specialized parts. Bone tools, though, were designed for field maintenance. A cracked needle could be reshaped. A dulled awl could be reground. A fractured spear tip could be reworked into a smaller implement. The raw material was locally available if hunting succeeded. This repair culture fostered deep material knowledge. Toolmakers understood grain direction in bone. They knew which parts of an antler were strongest. They recognized how seasonal growth affected density. This was, empirical science accumulated without written records. Survival in this context was not about carrying the strongest possible tool, it was about carrying something that could be sustained over time. That long-term thinking is honestly often absent in modern consumer survival culture, which emphasizes acquisition over maintenance. Prehistoric communities operated under strict environmental ceilings. Overharvesting meant starvation. Material waste meant vulnerability. As a result, technological innovation occurred within boundaries. Bone technology, really reveals restraint and efficiency. Tools were multi-purpose. For example, an awl pierced hide but could also assist in basketry or leather repair. A spear point might double as a cutting implement. Designs were carefully made to minimize material loss during shaping. This kind of efficiency actually parallels later military doctrines that emphasized supply economy. In prolonged conflicts, armies that rationed ammunition and repurposed materials survived longer than those that relied on rapid replenishment. The principle is the same. Resilience depends on sustainable throughput. There's a common misconception that prehistoric life was static, but in reality, bone tool designs changed as climates shifted and prey patterns evolved. During colder phases of the last ice age, needle production increased alongside tailored clothing. In coastal settlements, fishhook diversity expanded with dietary shifts. Bone technology adapted dynamically to environmental feedback. That adaptability really is intelligence in material form. When a modern hiker breaks a tent pole, the failure is typically chalked up to defect or accident. Rarely is it connected to resource cycles. The product is basically external to the environment in which it fails. Now, prehistoric tools could not be separated from ecological conditions. If prey populations declined, bone supply declined. If migration routes changed, tool forms changed. Feedback was immediate and honestly unavoidable. This closeness to ecological constraint cultivated strategic awareness. Groups had to consider long-term herd sustainability, seasonal timing, and terrain limitations. Tools were expressions of those calculations. In survival training today, there is growing recognition that understanding environment matters more than carrying premium equipment. Firecraft, shelter placement, and clothing layering depend on situational awareness. Prehistoric bone technology embodied that philosophy by default. It was not smarter because it was stronger. It was smarter because it was inseparable from environmental reality. As metalworking spread, it offered advantages in warfare and agriculture. Iron tools cut faster and held edges longer. States that mastered metallurgy gained strategic dominance. But metal required mining, smelting, trade networks, and centralized labor. It tied communities into expanding political systems. Bone tools required none of that. Their decline corresponds with increasing social complexity and hierarchical control. From a survivalist perspective, this shift is really significant. Technological dependence on large-scale infrastructure, well, it introduces a certain vulnerability. When infrastructure collapses, communities, must revert to locally sourced materials. Archaeological records from periods of societal disruption often show the re-emergence of simpler, locally producible technologies. Bone tools, for instance, represent a baseline capability. They are proof that advanced survival does not require industrial supply chains. There is a lesson here that, extends beyond archaeology. Preparedness is not about possessing the hardest or most advanced material. It's really about aligning tools with realistic maintenance capacity, environmental conditions, and long-term sustainability. Prehistoric bone tools functioned within a closed ecological system. They were repairable, renewable, and embedded in cultural knowledge. They demanded skill rather than consumption. Modern gear excels in performance metrics, strength, weight, efficiency, but it often assumes uninterrupted production and replacement. Bone technology assumed interruption. It assumed scarcity. It assumed that failure would occur far from resupply. That assumption produced resilience. The story of bone tools is not a nostalgic argument against progress. It's actually a reminder that intelligence in technology is measured not only by power, but by sustainability, integration, and adaptability. Prehistoric communities survived extreme climates, shifting ecosystems, and limited resources, not because their tools were crude, but because their tools were honest about constraint. Understanding that really changes how we evaluate modern preparedness. It encourages us to ask whether our equipment is truly resilient or merely advanced. If you value deeper historical analysis that challenges common assumptions and explores the overlooked foundations of survival and warfare, subscribe to Iron Age Instincts and share this video with others who take history seriously.